Good morning. So in this video I am going to discuss about Benzine condensation reaction followed by its mechanism. So first let us see what is Benzine condensation. So Benzine condensation, an aromatic aldehyde. In this reaction, an aromatic aldehyde reacts with aqueous alcoholic potassium cyanide. Aqueous alcoholic potassium cyanide gives an alpha hydroxy ketone is what we call it as generally benzoin condensation. An aromatic aldehyde on reaction with aqueous alcoholic potassium cyanide gives an alpha hydroxy ketone is generally benzoin condensation. Okay, right. So there is the equation representation of this reaction. An aromatic aldehyde on reaction with aqueous alcoholic potassium cyanide giving an alpha hydroxy ketone. Okay, so let us see an example for this. Actually, this reaction is also called as dimerization reaction because here two aromatic aldehyde combines and giving a product. So mere combination of two molecules of aromatic aldehyde, so that it is also called as dimerization. Okay. Now this is an example for benzyne condensation. So this is a compound with formula C6H5CHO, which is nothing but benzaldehyde, an aromatic aldehyde. The name of this aldehyde is nothing but benzaldehyde, isn't it? Right. Now benzaldehyde reacts with another molecule of benzaldehyde. Okay. Second one also nothing but benzaldehyde. Okay. Right. Now this in presence of aqueous alcoholic KCN, you are getting a compound like this. Okay. So which is also called as benzyne. The name of the product what you are getting here is nothing but benzyne, which is an alpha hydroxy ketone. Basically this is a ketone derivative, this is a keto compound. Then there is a hydroxy group adjacent to the function group, that is at alpha carbon, that's why it is called as alpha hydroxy ketone, but name of this compound is benzyne. Okay, right. Now here you can see that here only combination of two benzaldehyde molecules without elimination of anything. That is the reason why this benzyne condensation is also called as dimerization of benzaldehyde. Okay, right. Now, so I have given the IUPAC name of this benzyne also. Okay, right. Now I have drawn the benzyne again. Here, this is supposed to be considered as a parent compound, the keto compound with two carbon atoms. Keto compound with two carbon atoms. So it is supposed to be ethanone. What is it? It is supposed to be ethanone. So this is function group. So carbon number 1. Then this is carbon number 2. Now you can see at second carbon there is a OH group, isn't it? So that is called 2-hydroxy. What is it? 2-hydroxy. Then this also considered as substituent. A phenyl group over here, another phenyl group here. Okay, one phenyl group is at carbon number 1, another phenyl group is at carbon number 2. So that 1, 2 diphenyl ethanone. So now in this compound, the hydroxy group, this one, and these two phenyl groups, all these three are considered as substituent. Okay, hydroxy, diphenyl ethanone, hydroxy at second carbon, so 2-hydroxy, phenyl groups, one at first carbon, another one at second carbon, so 1, 2 diphenyl, 2-hydroxy, 1, 2 diphenyl ethanone. Okay, that is the IUPAC name of benzyne. Okay, so I have given the IUPAC name also. Okay, now let us see the mechanism of benzyne condensation. Okay, right. Actually here we do the reaction in presence of aqueous alcoholic KCN. What is it? Aqueous alcoholic KCN, isn't it? First KCN dissociates to form K plus cation and Cn minus anion. Okay, right. Now what is happening is the Cn minus ion, which is a electron rich species, which is nothing but a nucleophile. This Cn minus nucleophile will attack carbon atom of a benzaldehyde, carbonyl carbon atom of one benzaldehyde molecule. Okay, right. Now this way simultaneously one bond pair moves to oxygen. Okay, but now what is happening is this Cn group is getting attached with this carbon. So after shifting of bond pair to oxygen, it becomes single bond O minus. Okay, you get a species with a negative charge. What do you call it as anion? What is it? Anion. Okay, right. Now after this, what is happening is proton transfer. What is it? Proton transfer. That is the hydrogen which is present here, this hydrogen will be transferred to this oxygen as a proton, which means this H will be transferred over here as H plus. Now this comes over here as H plus. When O minus H plus becomes OH. When this H comes out here as H plus, now the bond pair will be retained by carbon. So that the carbon will become negatively charged. Carbon is becoming negatively charged, and when the H plus ion goes over here becomes OH group. Okay, right. So now you get a species in which carbon is carrying a negative charge, isn't it? Which is called as carbanion. What is it? What do you call carbon with negative charge is carbanion. Okay, right. Now this carbanion will react with another benzaldehyde molecule. This is the second benzaldehyde molecule. The carbanion which is formed from the first benzaldehyde molecule will react with the second benzaldehyde molecule. So what I have written here is nothing but the second molecule of benzaldehyde. Okay. So now what will happen is this carbanion being electron rich, it will attack the carbonyl carbon of the second benzaldehyde. Okay. Simultaneously this bond pair will move to oxygen, so that it becomes this carbon is getting attached over here. This carbon C minus carbon gets attached over here. Then when the bond pair moves to oxygen, it becomes single bond O minus. Okay. So as a result of this, you will get a species like this. CCH5 CCNOH single bond CHO minus, then C6H5. Okay, right. Now again one more proton transfer occurs. Again there is one more transfer of proton occurs. The transfer of proton occurs between these two species. That is the hydrogen which is present in this OH group will be transferred to this O minus group as a proton. But now, so actually what is happening is this H will be transferred to this oxygen as H plus ion. So that now what is happening is this O will become negatively charged. Okay, so now I have written that O is becoming negatively charged after the transfer of proton from this OH group to this oxygen. Now this is becoming as OH group. Okay, right. Now you get another species like this. Okay, then finally this compound, from this compound CN group will be leaving as CN minus ion. Okay, here what is happening, CN group will be leaving out as a CN minus ion. Actually that takes place by this way. These electrons are moving between carbon and oxygen. By the time the CN will go out as CN minus ion by taking this bond pair. Okay, now here you get a new double bond C double bond O. This your new bond is formed over here. Okay, right. That's what C6H5 CN goes out as CN minus ion, isn't it? That what you call as leaving group. Then C double bond O, C double bond O. Then already you have CHOH and C6H5 group. So it's nothing but the our desired product, which is nothing but benzoin. Okay, so alpha hydroxy ketone is a keto compound. Function group adjacent carbon alpha carbon, and there is a OH group. That's why we call alpha hydroxy ketone. Okay. So this is what the mechanism of Benzine condensation. Okay, I think you hope you understood what is it. The first, what is happening, the CN minus nucleophile is attacking carbonyl carbon of one benzaldehyde and giving a anion like this. Then in that there is a proton transfer occurs between this carbon and oxygen. This hydrogen will be transferred over here as H plus, so it becomes OH. So now this carbon, which is from which hydrogen is transferred, will get a negatively charged. What do you call it as carbanion, isn't it? Now this carbanion will attack carbonyl carbon of another benzaldehyde molecule. This is the second benzaldehyde molecule. Okay, right. So that after that, so you get a species like this. Here you have OH and O minus in the lower branches, right? So that the hydrogen present in OH group will be transferred as proton to O minus. So that this oxygen, OH oxygen will get a minus charge. That results in O minus, then adjacent oxygen will become as OH group, isn't it? Then finally that CN group will go out as a leaving group as CN minus ion, isn't it? Further the driving force is the electron rich oxygen. That excess electron of this oxygen is moving between carbon and oxygen, so new double bond formation. By the time that CN will take up this bond pair and go outside as CN minus ion, which results in formation of an alpha hydroxy ketone. What do you call it as? Benzoin. Okay, right. Right, I hope you understood about the mechanism of Benzine condensation. Okay, so good luck, keep watching. Thank you very much.